Today we're going to take a look at section 1.2, which is constructing models to solve problems. In particular, we're going to see problems that are word problems. And I know word problems freak people out sometimes, but I'm hoping that you will not freak out, but that you will have some strategies to be able to try after having taken a look at this in class today, okay? So to start with, and we're going through most of these, I know you already have things written down, so jot down things I say if you need to, or simply just listen. A formula is what we mean by an equation involving two or more variables. Usually it's helping us to find a specific quantity. And we're going to talk more later in chapter 2 about this one, a function. But a function is a rule for determining the value of one variable from the values of one or more variables. Okay? We're not really focusing too much on functions at this point, but it will come up at a couple different points in our discussion. These are some common formulas. Some of them you probably remember, some of them you probably don't, some of them you've probably seen written differently. Simple interest is interest that you get as like a one-time interest if you go and you give your money to the bank and after a month they give you the money back with interest. This is how it's calculated. P is the principal, so I don't have any of the letters written down, so if you're not familiar with the letters I'm using, please write them down. I stands for interest, P stands for principal. The R is the interest rate as a decimal, so if you're talking about like 5%, you can't put the number 5 in there, you've got to change it to a decimal form, 0.05, so remind yourself that R is a decimal. T stands for what? Time, and you need to also remember that the time it stands for is time in years. Okay, at least for most of the investment stuff that we talk about, it's time in years. Perimeter of a rectangle, the perimeter is the distance around an object. So for perimeter of a rectangle, it's 2 times the length plus 2 times the width. Your distance formula is D equals RT, looks like dirt almost, right? Dirt. You've probably heard of it that way even, right? Distance equals rate times time. Rate is how quickly something happens. The time here could be in hours, right? Like think about driving, right? Miles per hour, things like that. It could be in seconds. If somebody's talking about how fast they're running a very short distance, we talk about it in meters per second a lot of times, something like that. The temperature formula for converting between Celsius and Fahrenheit, there's a couple of versions of it. This is one of them. Celsius equals 5/9 times, in parentheses, Fahrenheit minus 32. Sales tax, you guys encounter this in Oklahoma every single time you go to the store. We all wish it weren't true, right? But we do. We encounter it every time we go to the store. The P stands for the principal or the amount you're paying for the object, plus the rate times the principal. Another version of this that you may be familiar with is that you may be familiar with a version that looks like this, where sort of the P gets factored out in front. So you take 1 plus the interest rate or the rate of, not interest in this case, but the rate of tax, and you multiply that by the principal or the amount of your objects that you're purchasing. Area for a rectangle, area is length times width. Work looks a lot like distance. Work is rate times time. Okay, the rate at which you work times the time that you work for. All right, so if you're working 5 math problems per hour times 5 hours, we would multiply 5 times 5. We could figure out how many math problems we can do in that 5-hour time length. All right, so we're going to jump right into some examples. We've got a few examples in here. Some are more applications-based than others. The first two are not very applications-based. They're just working with equations. I will say that this is like Algebra 1 content. I have a daughter who's taking Algebra 1 this year, and she came home with this the other day, and I thought it was kind of interesting. She was asking me questions about this, and I just made this lesson. I was like, I'm going to go teach that to my students, but teach is not really a good word. You guys have seen this before. This is something you've seen. So we've got an equation or a formula, right? And in fact, you probably know what that first formula is. What is that first formula? A equals 1/2 BH. Area of a triangle. Very good. It is the area of a triangle, 1/2 base times height. And this equation, or this problem, is asking us to take this equation and to solve it for a specific letter. In this case, the letter B. So we want to isolate the B. We want to move everything else to the other side. There's more than one way to do these a lot of times. And so, like for instance, the 1/2 right here in front, I could divide 1/2 to the other side. But then I'm going to have something funny. It's going to look like division by a fraction. That feels a little bit awkward. Instead of dividing by 1/2, you might choose to multiply by 2. right? That's another way of doing it. So if I were to choose to multiply by 2, that this would be 2a equals bh. What would I have to do to get b alone? Divide by h. So this would be one version, base equals 2 times area over height. One version of this solved for b. Not the only version, but one common version. Do you know what the second equation or formula is a formula for? It's not quite as common as the first one. Standard form of what? Yeah, it's the standard form of a line or a linear equation. And again, if you don't know that, it doesn't matter. I just threw it out there, okay? So, got ax plus by equals c, and we're trying to solve for x. What might you do first? Move the by, exactly. So if we move the by, we would do that with subtraction, right, Rebecca?
Yes.
Yes, so minus by. So we've got ax on the left, and we have c minus by on the right. The goal is to get x alone, so what might we do next? Divide by a, and make sure that we're writing all of it divided by a, not just part of it. So x equals c minus by. That's terrible, y. C minus by over a. The next one is weird. Agreed? Yeah. It's awfully tempting to just be like, oh, look, they're all in the denominator. We're just going to write down r equals r1 plus r2 plus r3, and that would not be true, so don't be tempted. We need to solve it for r2. There's a couple of ways we could do that. What would you like to try first?
Maybe we could subtract R3.
Subtract. Okay, so we can subtract the 1 over r3. We could also subtract the 1 over r1. So like everything that doesn't have the r2 in it, let's move it. So I've got 1 over r on the left, and I will subtract the 1 over r1 and the 1 over r3. Again, not the only way to do it, but it is one valid way. Works pretty well. All right. What would we like to try next? We could multiply by the reciprocal on both sides. The catch in doing so, and we may still do this, but the catch in doing so is that that's going to then put the R2 back on the same side that we were just trying to get it alone. You know what I mean? Like it's going to move it to the side that's got all the other R's on it already. So we might not want to do that right now, but eventually we will do something like that, yeah. You probably still, whether you're going to willing to say it or not, would still really like to just flip all these things upside down, wouldn't you? I mean, like, I look at this and I still see a lot of fractions that I'd really just like to flip. And in particular, the one on the right, where it's a single fraction, to flip it seems like a reasonable thing to do. And it would be reasonable if I had a single fraction on both sides. But I don't have a single fraction on the left, do I? I have 3 separate fractions. Are you okay, Andre?
Yeah.
Okay, you sure? All right.
Some water.
There's water. There's water down the hall, I think. Okay. All right. So in that sort of attempt or hope that we could flip these fractions, we could get the left-hand side to be a single fraction. And if we could do that, then we could flip the fractions on the left and on the right upside down, and then we would be done. And that would be kind of nice, because then we wouldn't move the R2 to actually be attached to something. Or at that point, we could cross-multiply, right? That would be a possibility too, which would be the equivalent of what Rebecca was suggesting. But either way, somewhere along the way, we're going to have to combine what's on the left into a single quantity, a single fraction.
So could you just put 1 on top over r minus r1 minus r3?
So let me ask that question for you with numbers. If I had 1 over 2 plus 1 over 4 minus 1 over 6, can I do that? Can I write 1 over 2 plus 4 minus 6?
You would have to get the same denominator.
Yeah, we need to get the same denominator in order to do that, to combine them the way that we're wanting to. So we need a common denominator. A lot of times when what we're trying to do with variables, if you'll put numbers in and ask yourself the same question, the answer becomes really clear of whether you can or can't do something. So it's just kind of a check step in your mind. All right, so we do need to get the same denominator like Anna had suggested. Right now, unfortunately, all the letters are going to feel like they're running together a little bit because I've got an R and an R1 and an R3, and I need all of them in the denominator. So I'm going to have to do an R1 and an R3 on the first fraction because they don't have those. On the second fraction, I'm going to have to do an R and an R3. And on the third fraction, I'm going to have to do an R and an R1. Those are all the pieces that are missing. So in the first fraction, well, all the denominators are the same now. Agreed? They all three have all three components, R, R1, and R3. Tim?
Do you need to do anything for the R2?
You don't have to, because in the end, what we're going to do once we get a single fraction on both sides, again, this is not the only way to do it, but since we have a single fraction on both sides, we'll be able to actually take both fractions and flip them upside down, and then R2 will be alone exactly like we want. So we don't have to do anything with R2 at the moment. Okay, on the left-hand side, then I'll put them in numerical order. This is R1, R3, minus R, R3, minus R, R1, and it's all over R, R1, R3. And the right-hand side looks super helpful at this point since it's so simple. 1 over R2. But again, kind of like I was answering Tim, the cool thing at this point is we're really done. All we have to do is to flip both fractions. And we can do that because there's only one single fraction. It's the only thing that exists on each side. Okay? So it is appropriate now to do a reciprocal, to flip the fraction on the right to say just R2, because that's what R2 over 1 would be. And then on the left, I would have R over R1 times, R times R1, R3, and then over R1, R3 plus R, R3 plus R, R1.
Isn't that supposed to be minus?
Yep, it is. Thank you. That's what happens when I zoom in too far. I can't see my subtraction signs. We'll fix them. Thank you.
R doesn't even look like a letter to me anymore.
Say again?
I said R doesn't even look like a letter to me.
It doesn't. We got
We're
to.
writing it
We're writing it so much it just turned into a number in your mind, didn't it? Yeah, it did.
Weird.
All right, problem-solving strategy. This is another one of those things where it's like I'm glad I didn't want to have to write all these out for you because this is a lengthy list. Problem-solving strategy, and this isn't like the only list of these problem-solving things, and not all of them look like this and so forth, but this is one version of problem-solving strategy. To read and understand the problem, sometimes that's the hardest step. I have my daughter coming home with Algebra 2 homework, and there's a couple things that I'm looking at. I had to read it like 3 times before I even understood the problems, and I have a PhD in math because it was just not making sense in my head, okay? So that happens sometimes. Read and understand the problem. Draw a diagram if needed or if it's usable. Sometimes diagrams don't make any sense, but sometimes they're extremely helpful. Decide on the variables you want to use, okay? There are some letters that don't work very well for variables. And sometimes just using X and Y is just the easiest thing to do, and sometimes it's not the most helpful thing to do. So you got to pick some letters that you're going to use some variables and write the unknown quantities in terms of those variables. Oftentimes you'll write equations using specific formulas. That's why I gave you a list of formulas that might come up. You're solving the equations, checking your solutions, and make sure you really answer the question they asked you. Don't go answering something else that you thought they were asking. Look back at what they asked you to find. All right, so here's an example. Very basic, straightforward kind of question. It's not even a very long one. But we do want to make sure that we understand the question being asked. If you borrow $100 and you pay back $105 at the end of 1 month, what was the simple annual interest rate? And you have to be careful because something weird happened in the middle of the problem. Did anyone catch it? Very good observation, Tim. I'm so glad you noticed it. Did anybody else notice it, or do you now? Hopefully you do now. You've got months and years within the same problem, so you need to be very careful. Right? This is one of those, did I answer the question they asked? Because it'd be really easy on this question to answer a different question, wouldn't it? Really would. Okay, so it says you borrow 100, you pay back 105. So taking a look at our sort of list of formulas over here. Oops, I missed it. Which one of these formulas seems reasonable to use for this particular type of problem, or for this particular problem? The simple interest one, where it says I equals PRT. You have to be careful. What did I stand for? The interest, right? Not the amount you paid back. So taking a look over here, I'll write that formula down. I equals PRT. What is the interest that you are paying? $5, right? You borrowed 100, you paid back 105. 100 of this is just because you had to pay it back. The $5 is the interest. It's the extra. So I is 5. What would the P be in this case? That's the 100 that you borrowed. Whoops. Your rate. Well, your rate would be in terms of, well, that's actually what you're looking for. Let me say it that way. And it usually is in terms of per year, like the annual part here where it says the annual interest rate.
So it would be 1/12.
Good job, Anna. That's right. So if your interest rate is an annual interest rate, right, in terms of years, then your time needs to be in terms of years as well. So if you borrowed it for 1 month, how much of a year is that? 1/12. Well done. Very good. So then, how are we going to solve this? There's more than one way. So somebody give me a next step.
Multiply 5 by 12.
All right, I like that step too. You could either simplify the 100 and the 1/12, which would be fine, or you could multiply the 12 to the other side so that you don't have to simplify it, because I'm going to tell you right now 112 is not evenly divisible, okay? So this will cancel this piece. What's 12 times 5? 60. And I've got 100R on the right. Then what? Divide by 100. What would that give me for R? Okay. Okay, so 0.6 is the decimal representation. What would that be as a percentage?
60%.
60%. Is 60% a big interest rate?
Yeah.
Oh my goodness. You thought $5, no big deal. But then when you see 60%, I hope you realize that that actually is a really big deal. Percentage-wise, or for a course of a year, if you did this like every month kind of thing or whatever, that's a lot of money.